Crude oil is one of the most important substances to our modern lifestyle. We use it in all sorts of things: pharmaceutical drugs, uh, polymers, plastics. We use it for fuel. We use it to heat our homes and drive cars and things like that. All sorts of modern materials are made out of it. And we're going to look at the substance itself and in particular how it forms today. So, crude oil is formed from tiny microscopic sea creatures. Now, there are various types of plankton. There's zooplankton and phytoplankton, and there's algae, and they have existed for millions of years. They still inhabit the sea. They're the bottom of the food chain in the sea, and they are basically tiny little creatures. Some of them are more like plants, some of them are like little shrimps. And eventually, over their life cycle, they will end up dying. And when they die, they will sink to the bottom. And they're very, very tiny, they're microscopic, but lots of them will die over a long period of time and sink to the bottom and become organic matter. Okay, so decaying sea creatures. Gradually, sedimentary rock builds up around them, so that's mud, silt, dirt, and that's really important because it stops oxygen getting to the decaying remains, and it kind of traps them under a layer of rock. The processes that happen then take place over millions of years. The decaying animals and plants and dead sea creatures, the plankton and the algae, will basically cook under intense heat and pressure. And this is a reaction which we call thermal decomposition. Thermal means heat, and decomposition means breaking down. So this is thermal decomposition of the dead plankton and algae. And under the right conditions, heat and pressure will cause them to turn into a gloopy substance which is black and kind of fluid, and that will form the crude oil. It's important that this is underground because there is an absence of oxygen. We call that anaerobic, because if there was oxygen, the sea creatures would turn into carbon dioxide and other molecules which would not make up more oil. They'd just float to the top of the surface as gas and dissolve into the ocean as other substances. So it's really important that this happens in the absence of oxygen. After a time, the decomposition will cause them to turn into this crude oil, and then millions of years pass, humans evolve, and we then need a way to get the crude oil out of the ground. So we drill holes and put pipes down and pump the oil out. Sometimes we have to pump something in to get the oil out, such as seawater or something like that. So it's slightly more complicated than it sounds, but we basically drill a pipe down and it will suck the crude oil up. Now, while that's happening, of course, we're drilling into the environment. We're going to destroy some habitats. Now, if it's on land, there's a lot of oil in Alaska, and obviously these oil plants have to go somewhere. They have to go into the habitat where stuff already lives. So land animals, birds, and if we're drilling at sea, also marine life, fish and things like that. And the habitat can be destroyed by the drilling itself, by the building of the chemical plants which refine the oil, or they can be destroyed by oil spills. So even tiny spills, they happen all the time. Big ones make the news, tiny ones don't, but they still have a big impact on the environment. Now, crude oil is not a limitless resource. Eventually, oil wells will run dry. We will not get as much out of them as before, because we consider crude oil to be a non-renewable resource. Now, what we mean by non-renewable is that it takes millions of years to form, but we have used an awful lot of it. In fact, we've used a huge percentage of the estimated reserves of crude oil in only about 200-300 years. We are using crude oil much faster than it's being produced. So it being non-renewable and it being so useful, one of the big questions for us in maybe our lifetime, but certainly very shortly for the human race, is, well, how are we going to get along without it when it runs out? And that's one of the big focuses of modern chemistry, is finding substitutes for this before it's too late.